Hello student, hello everyone. Today we're gonna discuss about types of reactions, which is presented by your chemistry instructor, Mr. Adisalim Yohannes. Types of chemical reactions. There are five types of chemical reaction we will use. The first one here, synthesis reaction, or it's have another name called combination. Second, decomposition reaction, which is the opposite of synthesis or combination reaction. Third, single displacement reaction. Fourth, double displacement reaction. And finally, the fifth one, combustion type of reaction we will have. Let's dive into each of them one by one. First here, synthesis reaction. What's the description of this synthesis reaction? Synthesis reaction occur when two simple substances combined and form single compound. As you see here now, A combined with B and AB is formed. When two things unite together and only one single product is formed, we can call it that one synthesis or combination type of reaction. Here are some examples of synthesis or combination type of reaction. So, hydrogen react with oxygen and water is formed. Carbon treated with oxygen, carbon dioxide is formed. Why we say that these two reactions are combination? Because we are combining two things together and we will get only single product. That's why we can call them synthesis or combination type of reaction. Here is the opposite of synthesis types of reaction. We can call it decomposition. What's the description of this decomposition reaction is? Decomposition reactions are the opposite of synthesis reaction. They occur when a compound break up into simple compounds. In reactant side here, AB you have, but when this AB is converted into A plus B, we can call it decomposition types of reaction, or it's have a name called another name called dissociation type of reaction. Here is a general formula of decomposition reaction. Product converted to reactant plus reactant. AB you have and it's split into A plus B. Example, decomposition of water is second one, mercury oxide decomposed into mercury plus oxygen. The third type of reaction is single replacement reaction. What are the description of this single replacement reaction? Single replacement reaction occurs when one element replaces another in a compound. It means that A replaces B on the product side to form AC and B alone. Here, mathematically, BC you have and A. This one is compound, this one is element. And in reactivity series, A is more reactive than B. That's why A displaces the position of B, then B alone and AC is formed. Here are a general formula. Element treated with compound and compound plus element is formed. Mathematically, here A treated with B, C, and AC plus B is formed. Again here A treated with BC and BA plus C is formed. Examples, For example, here, iron treated with copper sulfate, but in reactivity series, iron is more reactive than copper. That's why iron displaces the position of copper and ferrous sulfate plus copper is formed. In second reaction again, magnesium treated with hydrochloric acid, but according to this atomic size, magnesium have highest atomic size than that of hydrogen. So magnesium displaces the position of hydrogen and it forms magnesium chloride plus hydrogen gas. Here is the fourth type of reaction. We can call it double replacement reaction. What are the description of this double replacement reaction? Double replacement reaction occurs when a metal replaces a metal in a compound and a non-metal replaces a non-metal in a compound, forming two new compounds. As you observe here mathematically, AB treated with CD and CB plus AD is formed. This type of reaction have a name called double displacement reactions. The general formula: compound plus compound gives compound plus compound. What does it mean mathematically? AB, AB treated with CD, and here A displaces the position of B, A displaces the position of C, and C displaces the position of A. That's why AD plus CB is formed. Here are examples. Silver nitrate treated with sodium chloride, and in this scenario was going silver displaces the position of sodium and sodium displaces the position of silver, and silver chloride plus sodium nitrate is formed. The same is true when you are reacting this potassium sulfate with that of barium nitrate. Potassium displaces the position of barium and barium displaces the position of potassium. That's why potassium nitrate plus barium sulfate is formed. Here is the fifth type of reaction, what we call combustion. The description of this combustion reaction is: combustion reaction occurs when hydrocarbons react with oxygen gas to produce carbon dioxide and water. In combustion reactions, our products are carbon dioxide and water. Here is a general formula. This carbon having X and hydrogen having Y. As you know that hydrocarbons are a compound which consists of only carbon and hydrogen. But this X and Y indicates a number. Then when they are combusted to oxygen, they form carbon dioxide plus water it is. Here are examples. For example, an alkane with carbon number 5, it's have a name called pentane, treated with oxygen and carbon dioxide plus water is formed. And again, here you have the one with having carbon 10 and hydrogen 8. So this one fulfills the general formula of alkyne. So it's have a name called decyne. When decyne is reacted with oxygen, combustion takes place, then our expected product becomes carbon dioxide plus water it is. Now let's see here solved problems. The instruction says here classify the following types of reaction. For example, here you have sodium hydroxide treated with potassium nitrate and sodium nitrate plus potassium hydroxide is formed. So what type of reaction is this one? Double displacement. But our second reaction, we have here an alkane which consists of only one carbon atom, methane. When it reacts with oxygen and forms carbon dioxide plus water, it means that combustion type of reaction. Here you will have element and here you have compound. So iron displaces the position of this sodium, and here ferrous bromide plus sodium is formed. We can call it single displacement reaction. Here is also number 4, calcium sulfate treated with magnesium hydroxide, and here calcium hydroxide plus magnesium sulfate is formed. So compound plus compound, again compound plus compound is the product. Due to this reason, double displacement reaction. But here in number 5, you have lead treated with oxygen and lead bromide is formed. This one satisfies this synthesis parameter. Why that? Because we are uniting two things together to form only one single product. That's why it is synthesis type of reaction. Here, number 6, you have sodium carbonate, and it is dissociated and forms acidic anhydride and basic anhydride. So in reactant side you will have only one thing, and this one thing is converted into two. Due to this reason, it is decomposition type of reaction. Thanks for your attention. This is all about our today's lesson.